So the next problem is problem number 16, and we are given a triangle ABC with its coordinates, and we are making two transformations. The first one, we reflect about x-axis, we get a new triangle, A prime, B prime, C prime, and then we make counterclockwise rotation around the origin by 90 degrees, and we get the second triangle, A double prime, B double prime, C double prime. So the question asks which transformation actually brings this triangle back to triangle ABC. I think we did already half of the job by drawing the diagram. So marking the vertices on the coordinates plane is already very helpful, right? So let's see where the first transformation moves our triangle ABC. If it's reflected about x-axis, it's just the mirror of it, right? So my point C stays in the same place. My point A translates here, so it's going to be A prime, and my point C will be here. But my point B prime will be here, right? And C prime is the same as C. So my triangle is going to look like this after the first transformation. And what we do next, we make a counterclockwise rotation around the origin. So this is my origin. I should be careful that this is counterclockwise. Maybe some students want to rotate it clockwise, but I need to rotate it counterclockwise. So I can imagine taking this quadrant, number 3, and move my triangle to quadrant number 4. So what happens to triangle? Point C becomes C prime becomes C double prime. It translates to the point with coordinates 0, -3. This point translates to A W prime, and my point B is here. BW prime is here. Its coordinates, it's 2, -3, and this is 2, 0. So now I have my second triangle in the diagram, and I would like to find out which transformation brings it back to the original one, right? So we have 5 options listed, and the one that works is which one?
Well, we can reflect about the line y equals x.
Correct. So we can take the line y is equal to x, and we can see that this is just a reflection, a mirror reflection. And all other choices do not work. So I think this is the simplest way to solve this problem. The other way could be if we work with a particular coordinate. We can say we have a point P here with coordinates x, y, right? We can take this point and see what first transformation does to it. If we reflect it about x-axis, the new coordinate becomes what?
X negative y.
X negative y, correct. And then I want to find out what happens with my point if I rotate counterclockwise with 90 degrees. So to help me, I can, for example, take any point here with coordinates, let's say UV. When I rotate it counterclockwise, my coordinates become what? So this is my guess.
Negative u.
Negative VU, right? So if I had my coordinate x minus y, my new coordinate becomes
yx.
Right? So now I can see to bring back here, what do I need? I just can reflect it through the line x, y equals to x. Yeah, This is how you solve this problem.
All right, so I think for this problem, right, the main idea is just to draw the diagram and draw it correctly. And yeah, like Yvonne said, make sure you watch out for the counterclockwise versus clockwise.
Because I think there will be a definitely answer, another option for clockwise.
Right. I think if you rotate clockwise, they'll be reflecting about y equals negative x instead, which I believe was an option, right? So
It's actually not an option.
so it's not.
So people who did make that mistake might be lucky, but yeah.
Just kidding. Okay. Yeah, so I think the main idea for this problem is to draw a clear diagram. Make sure you get all the things right, get the reflection right, get the rotation right, and then once you end up with a diagram like this, it's very clear that we just need to reflect about the line y equals x.
You know it's not a rotation because the orientation changed, right? From here is A to B to C is in what order? Is in counterclockwise order, right? From here, A to B to C is what? Clockwise order. So you know it's not a rotation, right? And when you said you want to draw this diagram clearly and do it well, is another important thing is to make sure this is 3, this is what? 2. If your diagram somehow becomes 2 and 2, if
Then
you're
there's
not
no way to
careful,
tell.
then you cannot tell anymore.
Yep.
Right?
It looks
So
like
it's very important if you draw something, you draw it really is useful to be in scale,
Yep.
right? In this problem, actually you want not in scale in the sense of you really want to make 3 and 2 are very, very different. If you make them similar, then you are in trouble,
Right. Then you
Then
might
it's
think
very,
it's a
very hard to
rotation,
see.
like 180-degree rotation.
right? So they give you help. The problem posers are very nice. They give you 3 and 2. They want to see your habits. They didn't give you 2 and 2 because that could actually mislead you more, right? So another thing is if you are doing this kind of problem, I would say this: if you have a color pencil, I would draw this side a different color. Then I will clearly see, even it's 2, 2, I know this side goes to where. See, if this is purple, then this will be purple, and this will be purple. So I know, it's more coming from a reflection, right?
That's a good point.